Welcome back, guys. Juju here, and we are going to finish up our polymorphism project here. So what we're going to do is we're going to copy this, and we're going to go ahead and create our other class, and I'm going to call it circle. And why do you hate me? Okay, let's fight with it again. Can I remove this? Can I? That'll do for now. I'll just squish it over so it can't even move. Or I hope it can't. Oh. Okay, so I forgot to extend shape when doing that. So make sure you do that. So what I'm going to do now is I'm going to do public circle, create our constructor, but I'm only going to take one parameter, and that's the radius, or diameter. And so how this is going to work is we're going to call our superclass like normal, but I'm going to pass in diameter through it, and I'm going to pass in -1 for the height. And if we go ahead and copy that, and alright, and now we have our extending, but the area will equal, we're going to do another way to get pi is we can use the math class, which is automatically incorporated into every Java program, but it's usually standard across all languages, and math.pi is will give us pi automatically, so we don't actually have to worry about it erroring. But the thing we do have to worry about is casting it so that it will return as an integer instead of a double, because pi is 3.14159,269. So what we have to do is we have to just tell Java that take this number and go ahead and make sure that it is in fact an integer. And I realize that it's probably a pretty bad idea, seeming that it is in fact a float. So maybe I'll go ahead and change that now. Just change this to float real quick, and float. And rectangle is going to have a little fit because we didn't say that we were going to do that. And just put flow. That's look bad. Anyways. Alright. So math.pi times pi r. So width divided by 2. But to the exponent of 2. So what we're going to have to do is go ahead and call the math class again. And the math class has a lot of useful things for math, such as square rooting and exponents. So I'm going to go ahead and put brackets around this, and it's going to take the base number and then the exponent. That should do it. And for the parameter, what we're going to return is oh, we actually don't want this anymore. Forgot to remove that. Math.pi, because you are thinking. So let's go ahead and say 2f. No, you're not going to take that. Okay. Cast it float, I guess, because it's going to return a double. Now for the parameter, it is 2 pi r. So let's go ahead and go 2 times math.pi and times why width Seriously, can't I just type normally for one video? Okay. And if we go ahead and add an F somewhere, maybe it will give us oh, that's another thing we need to do is 0.0. Otherwise, if it isn't a decimal, it's going to error at us and not be so friendly. And I'm going to cast this float as well. Okay, so I know that we were supposed to learn about polymorphism, but you also learned about casting, so that's always useful. Alright, now let's go ahead and quickly use our polymorphism. Now, as we all know, if we create an array of rectangles and circles, we'll need two separate arrays. Well, that's actually wrong unless we go ahead and create a shape array. And so I'm going to go ahead and call this shapes and say new shapes. And I'm going to have 5 total shapes. And alright, and so what we're going to do is, well, first remove the S because the class is called shape, and let's go ahead and do shapes, and we access each element in the array by using a subscript. So let's go ahead and say new rectangle, and I'm going to say 200 and 100 for this one. And let's go ahead and just paste these right away. And this is 1, this is 2, this is 3, and this is 4. And so this will be, I'm going to make this one a circle, and this one a circle, and because they only have radiuses, or diameters, so this one is going to have 60, and this one has, let's say 80. This one will only be 100 by 50. And this one will be 25 by 300. Okay, and now what we can do is we can loop through the array, and I'm just going to type 5 and I++, and then we just go system dot out dot, and instead of print line, I'm going to print, but I'm going to do print F. And if you remember from the formatter how we formatted, that's how I'm going to do this. So what it's going to take is shapes, shape, and then do %d is how you represent an integer. And so hold on a sec. Okay, so %d is how you represent an integer, and from here we go ahead and then we type the rest. So has area of, and percent, oh, what is float? I think float is a F. I'm not positive, but I'm sure we're about to find out. Perimeter of %f. And so because of how we set it, we need to pass in a d, so I, and then shapes I dot get area and shapes I dot get perimeter. Alright, and so just like that, it's kind of long, but yeah. So let's go ahead and run this. And we forgot to add /n. Sorry, I looked ahead without showing, but basically it's just one mess on one line. And let's go ahead and look at our code, and what has it printed out? It says that shape 0 has an area of 20,600, and 200 times 100 is 20,000, and for 2 times, or sorry, width plus height is 300 times 2 is 600. So yes, the perimeter and area are correct. To make sure, let's go ahead to the last one. And oh wait, I don't know how to do pi in my head. Whoa. I'm just gonna assume the circles are right. If not, I'm sure someone will leave a comment down below. And okay, shape 3 has an area of 25 by 300, so 25 times 300 would be, oh, that, is that right? Yeah, yes, it is right. I had a bit of a brain fart there. And the perimeter would be, let's see, 650? Yeah, and it's 650. Alright, so it seems that it worked. I hope you learned something here today. If you found this tutorial useful, go ahead and give it a like. If you haven't already, make sure to subscribe for future videos. And this was Choo Choo. Thank you for watching, and see you in the next tutorial.